everyone. Today I would like to show you three different solutions that someone could generate in C# for the solving palindrome problem. I will be not getting into the details about palindrome that could be a sentence with capital letters, commas, the apostrophes, because this is outside the problem. Usually when you get this problem you will be getting a single word to check it or a number, that's depends, and everything is in a lowercase. But in a real life scenario, if you want to think about it, you need to think about that you will get a sentence that is a palindrome, and we have few examples of sentence like that is: don't nude, what it a car or a cat I saw, Eva, can I see bees in a cave, Madame in Eden, I'm Adam. So that's a palindrome as well, even if this is a sentence. Most of us, the palindromes like rotator, did, be, whoa, kayak. That's what we know, and usually use an example or just made letters that are having. So for today, I have three different solutions that could be done and resolved. The first is I would say, a low-level approach. So what we are doing here, let me try to explain this snippet. So first we try to take the array size is the length of the given string p1, then the loop size is half of the array. So what we are trying to do, we are trying to compare this with so the first element with the last element, the second and last with the second last, and in a situation where those guys doesn't match, we have the fail fast approach. So we are changing the result variable and we are breaking the loop, so we don't need to process other elements when we found that there is an issue. And that's the thing. Let's try if this is working. What's going on here? I probably have some select, so we have a true. Let's give something that shouldn't work, and we got false as a result. Maybe it's not visible, but yeah, this is the result. So we know that this is worked. For me, it's a kind of low level approach. This could be solved in a very fast way. So what we can use, sorry for the formatting, oops. We can reverse this string and then compare if the p2 is equals p1, so the given string. That's very easy. So reversing, let's say what is the result, and the result is true for our peep. Let's break it, create something that is not true if we're changing. So that means the test is working. I would say very smart approach. We just reverse it, and that's cool. I would say a two-liner solution. We can make this as a one line using the sequence equal. Again, it's a link command. So let's check if this is working. We know it's true, so it should working. Let's try to destroy it, use a different thing, and we got false because the sequence is not a palindrome, so it's not matching after it's reversed. So this is something using this approach where we reverse the string, but we also compare the sequence. Now the thing behind that is everything looks good, but if you want to think which one of those guys is more, I would say, performance, where we are getting the more performance, the first, second, third. So I created a kind of test. Let me try to fit it in a window. So what we have timing, we be running this 10,000 times. We have let's format this because we are humans, so we want to see this as a human. So we have 8, it's 42 characters and another long sentence. And I created a class that literally has first solution, which is our array scan, second is the reverse, and the second is the sequence equals of the reversed one. So when we run it, now we can see results. We see that the array is growing linear with the amount of text we have. So we have 4, 8, 42. So from that is around 4 times more. I would say even more. But the other elements where we use abstraction that is built in the language, which is a linku, are having more drastic times. And we can see it at the end where the simple method takes only 32 milliseconds and the sequence equals is taking 200. Why that happens? So when we try to see the EL native code, I think I will go over the methods because that will be easier for us to see. Let me explain this. What we can see in the intermediate language, we have string get characters, and then here we have only extensions, but we are not calling any external method. When we go to the query tool, what we have here, we have 2 external calls to reverse array, and then finally we have the string equality. And this is something that takes CPU time because we need to load a code from a different DLL. It's not the simple system approach. So with that, we add abstraction, which is easy for us humans to read and implement. But at the end of the day, we are adding an extra CPU ticks. That's the outcome. And in the sequence, we have 2 calls to different elements, and that's probably the comparison behind that is giving the timing. So as we can see, the stupid code that has only array scan is the most effective in this particular case, mostly because we are not using any external libraries. We are like in the system area. This query is faster, easier to understand for us as a humans, but from other point of view we are losing a bit of the performance. And finally, the sequence equal, this is a geek programming to create a 1 line of the code, but you are adding a lot of abstraction, which means like we generated a very short intermediate language, but we lost a lot of performance. So I hope you find it interesting with the comparison. You can use Linkupad. It's a free program which gives us ability to see what's inside the intermediate language, which is generated by the compiler. Thank you. Enjoy your time.